Hello and welcome to this lecture on Chapter 6, Application Software. This chapter has 8 learning objectives, and this recorded lecture, the chapter material does, and this recorded lecture is going to go through those 8 learning objectives one by one. So you don't have to read them all there because I'm going to repeat them for you as we see each learning objective. The first one is actually 3 learning objectives. Describe application software. What is the difference between installed and cloud software? And what are the different types of ownership rights? So, describe application software. Application software is the software that you use as a user to do the things that you want to do. The application software requires the operating system software, which is the software that tells the hardware what to do. System software was what we talked about previous chapter, chapter 5. Hardware, CPU, disk, mouse, printer, all that is what we talked about in Unit 1, chapters 2, 3, and 4. So all that hardware and all that system software works together to give us an environment that seems easy to use, and to us it is. You want to run a spreadsheet, just double click on the spreadsheet icon. The operating system interprets that instruction and pulls up the application program, Excel, or whichever we're working on. You want to browse the web, double click on the icon for the web browser, and the web browser and application program launches, and you start interacting with your web browser program by clicking on the links and doing all the things that you're used to doing. So application software are all the programs that you as an end user use. We don't technically use the system software other than to launch programs, delete programs, but for productivity, application software is there. In fact, sometimes application programs are called productivity programs. And Microsoft Office is definitely called a productivity suite, but they also have programs by Adobe Illustrator, Adobe Photoshop. Intuit has a money program used for taxes, a lot of small businesses use, and so on. What's the difference between cloud-based software and software that's installed on your machine? And it's literally that you either install the ones and zeros that are the program on your physical hard drive, on your physical machine. That would be the example on the right here. Or the ones and zeros that are the instructions of the programs that you're running. They don't actually exist on the hard drive in the same room that you're in. They exist, ones and zeros, on some server that you access through the internet or the cloud. So you're downloading the instructions as you need them, and then when you're done running that program, if you turn off your computer and restart it, you don't have those ones and zeros on your machine anymore. You want to run that program again, you would have to go into the internet again. As network connectivity becomes faster and more reliable, the idea of cloud-based software and cloud-based service as a software becomes more and more popular, and we're seeing more and more moving toward on-demand cloud-based. Microsoft Office, by the way, used to always be on this option on the right that you got CDs and you installed the CDs and put the programs there. Microsoft Office 365 is on demand, and when you license Office 365 for a year, you get the latest version of Office, and when they upgrade the version of Office, then you download the newer version of Microsoft Office on your machine, but it's not physically installed on your machine. Actually, they do install some of it on your machine, so it's a little bit of both. But it's not a physical CD for sure. Even the installation, what does get installed on your hard drive, gets installed through a network download, not through a CD. What about licensing? Well, most software that you use, you probably pay for and you license it from the creators of the intellectual content, the people who write the programs. Microsoft Word, Microsoft Office, software from Apple that you put on your Apple OS and the programs you run there, and even third-party programs, the apps that you put on your smartphones, on your tablets, or the programs that you install, Adobe Illustrator, on your desktop machines. Those are licensed software. What you're actually paying for is a license. But there's a whole nother group of software out there called open source software, and the most famous of these is probably Linux, the open source operating system. And by open source, we mean that literally the code base, the raw code that makes up the executable program, is publicly visible and open, and anybody can see it and review it and make changes and edit it. Kind of like Wikipedia, but for software. And it's something that you would probably have to have some professional training in software development to be able to contribute to. You and I can contribute to Wikipedia. All we have to do is create a Wikipedia account, give a username, password, create an account on Wikipedia, and we can edit content on all the Wikipedia pages. Open source software, technically you could, but you really would have to have a little more training to be able to contribute to that community. But the people who do contribute to that community, they write some great software that is open source. And the Linux operating system, because it's open source and it's freely available, it is used on a large number of computers, especially servers, web servers, cloud servers, print servers, database servers that are just dedicated in the background, responding to requests and providing the files that they need. Linux is certainly not the only open source program. Some other open source programs include OpenOffice. So you have a free version of Microsoft Office if you want to try that, and it works reasonably well. The browser Firefox is open source. It's not developed by any one person, by any organization. The raw source code for Firefox is out there. You can view it if you want to, and you could edit that if you had the skills to contribute to it. And a number of others that we see on this list are open source. Okay, learning objective number 2. Detail some concepts and commands that many software programs have in common. And I think in the example that we're looking at in the book, we're emphasizing Microsoft Office. So let's talk about Microsoft Office programs in particular and what they have in common. One thing they have in common is this notion of the ribbon. It's about an inch or so at the top of the screen, and it has tabs, and what you see on these 3 screenshots are the insert tab at different widths, because the contents of the ribbon will resize and adjust based on how big the window is as you have it open. If you want to see this for yourself right now, you can open up Microsoft Word and make the window slightly less wide and slightly less wide and watch how things change. So for example, this last group, so there's the insert tab we see in all 3 of these pictures, and there's a group, and all 3 of these pictures have the same groups: pages, tables, illustrations, links, header, footer, text, and symbols. Pages, tables, illustration, links, header, footer, text, and symbols. So we have the same groups under the insert tab, but there's just not as much space available for all the groups to be fully expanded. So look at the last group, symbols, here. In the widest version of this ribbon, the symbols contains equations and symbols as large graphic with drop downs. As the window gets a little smaller, the symbols is not quite as wide, and the equations and symbols has been shrunk a little, and even smaller, we just get symbols with the little drop down arrow. You can do the symbol version, but the equations is hidden, and you have to see that by clicking on the drop down. And some of the others shrink more quickly than others. So links is very small in the smaller group. The table is the same size through all of them. It didn't really change. You can see how the pages did similar to the symbols. We went from 3 large graphics to 3 small graphics to a single graphic. But it's the idea. So, and that's a really neat way to visually get at a lot of the functionality that exists in each program. And you'll see the same ribbon on all the Microsoft programs, and now other programs are mimicking this ribbon as well, even if they're not produced by Microsoft. That's not something they own a patent on that can prevent other companies from using it. In fact, because it's familiar to so many people through Microsoft Office, we're seeing other programs use it as well. And there are some things that are common across all these programs, not just Microsoft Office, but you'll really see this in Adobe Illustrator or XYZ Money Company or whatever it is. You're going to see these certain commands: open and save and print and cut, copy, paste, and undo. Those commands, you almost expect those to exist in any program you create from any desktop developing program. You expect to be able to do a save versus a save as. For example, I don't have save as on this screenshot, but save takes the file, the current file, and updates it using the same file name, same location, updates what's saved there. If you do a save as command, which again we don't have shown here, the save as command gives you a copy of the file either with a different name or in a different location, or both. So you end up with 2 versions of the file, not 1 version, doing a save as. You expect both of those to exist. You expect cut, copy, paste to exist on every program, and you expect the same keyboard shortcut Control X, Control C, Control V to work for cut, copy, paste in every program that you use. That's just become a standard and a de facto, and most programs adapt to that. By the way, the F1 key almost always means help, and that person's shirt there is kind of saying, "Help, I need somebody," with a bit of a Beatles theme to that playing in the background as you listen to it. Quick quiz number 1. Software programs that are distributed on the Honor Code system can be legally and ethically shared with others. To try out the software is referred to as, now that's shareware programs. One of the things, I didn't have a slide on that, but it's in the chapter reading. The idea behind a shareware program is that you eventually want the person to pay for the program, but you want them to try it out for free. So if you don't have a big marketing budget and you don't have a big development team, you kind of write software, you think it's going to be successful, you think people are going to like it, but they're not. It doesn't have the name recognition that people are going to invest $10 or $15 or $5 before they've ever tried it out. You can release the software using a shareware version that people are allowed to use it and share it for free, but then if you find yourself using it on a regular basis, you're encouraged to then at that point say, "This is valuable to me and I will give you $10 or whatever the asking price is for the shareware software." True or false? Software, the other two, by the way, commercial software, that's where you pay for it, whether you get a CD and install it directly or you pay for it and download it through the internet, but you pay for the program up front and you do not get your hands on the source code, you just get the executable. And then public domain software, that's what we're talking about, Linux and open source, where the code is visible for people to review, inspect, and edit. Question 2, true or false? Software purchased via the internet is always in downloaded, non-packaged form. That's actually false. You can buy something through the internet and they still ship you the CDs. So you have that option when you purchase through the internet. But quite frankly, it's like, well, why do I want that? It's usually an extra cost, or it's often, I don't know if it's more often than not, but it's I've seen it before. You can purchase a piece of software and you can download it for free immediately, or you can pay the extra cost for the physical media to be sent to you and shipped to you, and you get so you pay more and have to wait longer. So I think most people choose the free download. That seems like a better option. But you do have the option of having the physical CDs if you just like the comfort of them being in your house in the event you want to install it on multiple machines or have it for a backup. Question 3. A group of related software programs sold together as a unit is called a suite, and specifically a software suite. And we see these on utility suites from last chapter. We see it in Microsoft Office is a suite that has word processing, Microsoft Word, Excel, which is a spreadsheet, PowerPoint, which is a presentation program, Access may or may not be in the suite, a database, and other programs may or may not be in the suite. Okay, chapter learning objective number 3 of these 8 learning objectives. Discuss word processing and explain what kind of documents are created using this type of a program. I'm not going to say very much about Microsoft Word. You've got the book, you can read the chapter, and you might, as you actually read through Microsoft Word, find that to be informative in a way that is, like, wow, I've used Microsoft Word my whole life, or word processing my whole life, and I've never realized everything that I was doing there. But Microsoft Word contains features for editing your code, which is where you change the actual content, formatting your code, which is the look and appearance of it, bold and italic and larger font sizes and font types and all that, and just the general layout and flow of your program, putting in artwork, putting in graphics, putting in tables. Microsoft Word's a very nice feature. We used to have something called desktop publishing software, which is different than word processing software, but Microsoft Word has become so powerful that we don't really think about desktop publishing as a different program. If you're willing to put in the time and effort, you can do a high quality flyer, high quality brochure, even a high quality manual that you typically would think of as desktop published. You can do all of that in Microsoft Word. And as you can see on the screen, there's lots and lots and lots of things in Microsoft Word that are going on. I think actually reading through this, you might find some things that you were doing and you didn't realize you do that can speed things up just a little bit for you. This ribbon across the bottom, that's not called a ribbon, but this strip across the bottom, for example, has information in it that can be really useful, not just in Microsoft Word, but in all the Office suites. You got your little zoom in, zoom out in the bottom right hand corner. You got some ability to change the view in the bottom sides of the corner, page count, and all those things, and so much. So you've got that in your chapter. You can read that at more detail as much as you want about Microsoft Word. Learning objective number 4, explain the purpose of spreadsheet software and the kinds of documents created using this type of program. Now in class, when we talked in class, we talked about spreadsheets in some detail. And if you're watching this before we had class on Wednesday, then we will talk about this in detail in class. Spreadsheet is a very powerful program that business professionals use, and people don't know about it. It can make your life a lot easier when you're working with data. If you want to create charts, if you want to do totals or do some mathematical functions, Excel is a fantastic program for using this. At the top of the screen, what we see is an old Excel spreadsheet, not Excel, an old spreadsheet in a DOS-based world before there was Excel. Spreadsheets have been around since personal computers in the late 1970s, early 1980s. Spreadsheets have been around. They were one of the programs that made personal computing a must-have in the late 70s and early 80s, because they allowed you to have rows and columns, and it works exactly like Excel does today. You've got rows and columns. The columns are lettered A, B, C, D, and the rows are numbered 1, 2, 3, 4, and every time a row column intersects, you have a cell. So in the figure at the top with the green background, we see that C11 contains the word total, and it's highlighted there. In the figure at the bottom, we see that D7 contains the number 109. And you can see that a modern spreadsheet is much easier to look at, much easier to visualize and see what's going on. But the idea is still the same. Rows and columns intersect into cells, and cells contain numbers and labels, descriptive text, and formulas and functions that begin with an equal sign that tell Excel to do some processing. And those formulas and functions can be built in things like getting a sum or getting a count or getting an average or calculating a standard payment, a monthly payment on a car payment, or the present future value for a financial calculation, or whatever it is. Any formula that exists in any college textbook, Excel knows about it. And Excel will do the calculation for you automatically. You provide it the data, call the function, it'll do the calculation for you. You can also do formatting, just like you can in Microsoft Word, make fonts larger, choose font sizes, do background colors. You can see that the figure at the bottom there with the t-shirt cells looks much more formatted than what we saw in the early 1980s. But the idea of a spreadsheet is still the same. And what spreadsheets can do for you that's so amazingly powerful is they can do graphics for you as well. And we'll look at that in class, or we already saw that in class. And it's in the book also. Quick review here, talking about talking about cells in Excel. The phrase an absolute cell reference, a relative cell reference, and a function, these are all terms that we use in Excel, and terms you should probably know. An absolute reference has dollar signs involved, so number 2 to the right, $D, $4 is an absolute cell reference. And the purpose of an absolute cell reference is that when you copy a formula or a function, if you have an absolute cell reference, it does not move as part of the copy. So if I copy a formula or function down, all the cells go down with the formula and function. That's a relative cell address, and that's the normal way. But every once in a while you have a cell that's a fixed value, a fixed total, or a fixed person's name, or whatever, and you don't want it to copy when you move the formula or function. $sign before the row, $sign before the column will cause it to be fixed and not copy as you move. Relative cell address is like number 3, B6. If I copy that down, it becomes B7. If I copy it to the right, it becomes C6. And it will move automatically as I copy. It'll move relative to the direction the formula is moving as I copy. And then a function, sum or count or standard deviation or future present value or future payment or whatever it is, you just begin that with an equal sign to tell Excel, hey Excel, I want you to do this calculation for me, and then you give it the name of the formula or the function and it does the work. Learning objective number 5. Identify some of the vocabulary used with database software and discuss the benefits of using this type of a program. Now, a database program is a very powerful idea. Not as powerful as Excel. It's not as easy to use as Excel, and you won't be hands-on with databases as often, but databases hold data in organized ways. We wouldn't have Amazon if we didn't have a database for storing all the books that Amazon have. We wouldn't have at the university all the students and the student records and the GPAs of every student. That's easily managed in a database, and if it was done by pencil and paper, by hand, by human, it would be very tedious and very time consuming. So databases are very valuable. And without getting into too much detail on databases. Let me tell you, there's a few terms that if you know these terms, that when you do get into database later, and you might in your 243 class, or you might in some other class down the road get into it in details, these are the terms that I want to plant seed in your mind and still make sense to you down the road. We know about input, process, storage, and output, the terms that are in black there on this figure, because we did those in hardware. We've already seen those before, right? There's special hardware that converts the real world to ones and zeros so that it can be processed. Once it gets into the system, we process it using CPU and memory. We have storage, which is non-volatile, long-term ways to save the data, CD, DVD, thumb drive, magnetic storage, right? And then outputs are the ways of taking the processed value-added information and getting it back to the real world, whether it's a monitor or speakers or a printer or a 3D printer. Those are the topics of Unit 1, right? Chapters 2, 3, and 4. Well, with a database touches all four of those elements. When it comes to a database and inputting data into a database, a form is the term we use for how to get data into a database. And the reason we have forms with our database is we do validation of the data on the front end. So if you're entering a person's how long they've worked for a company, and you're entering a person's age, you don't want their age to be less than how long they've worked for the company. That is, you can't say a person is 25 years old and they've worked for the company 30 years. That obviously doesn't make sense. And if you put bad data into your database, it's going to cause a problem down the road. So with a database, one element of a database is doing data validation on the front end, trying to make sure that you get good, accurate data in your database, because that's going to give you a better database long-term, better results. So databases have forms which have code behind them and data checking behind them to make sure that the information is correct. You can't do a phone number that has a letter in it, right? That's not a valid phone number. You can't do a social security number that has a phone number in it, and so on. So there's things you can do to validate your data. Now, once the data is validated that it's more than likely correct, at least we've gotten rid of the egregious data, we put it into our system. It gets stored in our system in tables, records, and fields. Tables are the big thing. So we think about WKU, there's a table for students, and all the students at Western are in the students table, and every class that Western has is in the classes table, and every instructor that Western has is in the instructors table. And the information about each specific student is a record. And the information about each specific class is a record, and the information about each specific instructor is a record. And that record, there's multiple things you store about each record or each instance. So for me, there might be a field for me, in the instructor table, my name, Dr. Thad Cruz. There might be a field in there about my office phone number, 270-745-4643. There might be information in there about my office number, Grice Hall 210, and so on. So all that information, the classes that I'm teaching in this semester, so 141 and BI 410 and whatever else I'm teaching, right? So those are fields. You have fields that include your name, your mailing address, your local mailing address, your major, your hometown zip code, right? There's records and fields about you. There's fields about you in your records. So those terms exist. They're all stored on long-term non-volatile storage. They're all on a hard drive, a magnetic hard drive or CD or some type of storage medium. Queries, this is where databases earn their power. It's because of queries that we have databases. This is the processing. This is the value added of a database. It allows you to go out there and make commands like, tell me all the students at WKU who have a GPA of 3.8 or higher, and boom, it pulls that out for you. Or tell me all the instructors at WKU who have teaching evaluation scores of 4.5 or higher, boom, and I can get all those. Or tell me all the classes at WKU that has seating capacity of 45 seats or higher, boom, you can get that information. So anything that you can want to pull out of the database, you do that using a query. And then reports are just the way we get our results. You have options of having very structured, very good looking printed reports, and that's our output there. So those terms, forms, tables, records, fields, those are all storage. It's very big tables, records within the table and fields within the record. Queries, how we get the information out of our database, and reports are how we present the results of our queries. Well structured, well formatted, just like a well formatted document in Microsoft Word. You can do a lot of that same formatting with a report in Excel. Okay, I could get into a lot more information on this. We could have an entire class on this. I just want you to be familiar with those terms. By the way, here's a little question at the bottom to see if this makes sense. For a customer database containing 50 customers, so we're talking about customers, that's going to be our table. 50 customers, there's going to be 50 records in our table, and each record is going to have customer's name, the customer's number, last name, street, city, state, zip, and current balance. Answer these questions. How many records are there? There are 50 customers, so there's 50 records in this customer table. How many fields are in the database? Well, customer number 1, last name 2, street, that's the 3rd field, city, that's the 4th field, state, 5th field, zip code 6, and current balance 7. So there's 7 fields. And to display a list of all the customers who live in Texas and who have a current balance less than $10, we would use a query and pull that information out. And that's what's cool about a database is that once I get data in, I can query out the information really quickly and really specifically. Changing the line spacing of a document is an example of line spacing that is a formatting thing. So that would be letter C, yes. Editing is changing the content, but just going line spacing, that's not changing the content, that's changing the presentation. That's why it's formatting. True or false? When using an Excel function such as count or sum, you first enter an equal sign in the cell. That is true. It's how you get Excel's attention and tell it that it's going to do an action there. And number 3, a spreadsheet document created in a spreadsheet program is often called a worksheet. I don't think I mentioned that, but the rows and columns are a worksheet, and you can actually have more than one worksheet in your spreadsheet file. The spreadsheet file itself is called a workbook. So that's in your reading, workbook versus worksheet, the file versus a single spreadsheet within the file. There's those terms. Almost done. 6, describe what presentation graphics and electronic slides shows are and when they might be used. So Microsoft PowerPoint would be a program for working with presentation graphics. You've already done your PowerPoints, SAM projects at this point, more than likely. You can see, so you're probably familiar with this material. I'm not going to spend much time on it in this lecture today, but one thing you will see is there's a ribbon across the top, which of course is true for all of our Office Suite programs. As you look at a specific slide, you can do graphics, you can do transitions. It's more important, and you can do charts. Charts are very, very, very powerful, and you can use Excel to build your charts, or you can do some charts within PowerPoint or the presentation tool as well. But more important than the twists and the turns and the bells and the whistles, it's being a good, effective communicator. And the reason you did the PowerPoint activity where you gave a initial project and then we revised it later to make it more visual is because professional presentation software in this day and age, in the 2000 teens, people use graphics. They use highly visual, minimal text if you're giving a professional presentation. So slideshare.net is a great place to go and look and getting a feel for what really good presentations look like. So as you use a presentation tool, you can use PowerPoint to give the world's worst presentation, and you can use Microsoft PowerPoint to give the world's best presentation. And the skills to do the world's best presentation are on display in slideshare.net and other similar places. Learning objective number 7, list some types of graphics software that consumers use frequently. Well, for graphics software, Adobe, not Microsoft and not Apple, but Adobe, a different company, probably makes the world's best-selling graphic software with Adobe Illustrated and Adobe Photoshop. Those are probably the best selling and best known programs out there for doing graphics software. But there are many others out there, some of which are freeware open source, some of which are shareware programs that if you use them and like them, you can then pay for them after the fact, some of which are proprietary software like Adobe, but they're created by companies other than Adobe. And you can find a large number of those programs out there. They all work somewhat similarly, and they all probably have more of a learning curve for them than you have for Microsoft Word. The first time you pull up Illustrator or Photoshop, if you've never used them before, you will not be completely intuitive about what you're supposed to do. But they're very, very powerful programs, Photoshop and Illustrator are, and some of these other programs are simpler to use, and some of the other options are more complicated to use. But if you want to get good at develop the skills at editing photos and creating illustrations, then there are tools out there that will allow you to do that. And our last learning objective, name several other types of application software and discuss what their functionalities are. Well, it's whatever you can think of. And it's like saying describe all the apps that are available for your phone. There's all kinds of them. And same thing, programs for your desktop. There's probably more apps for your phone than there were programs for your desktop, because app developers, there's more people with smartphones than there are people with desktops, so app developers are developing for smartphones and tablets even more than developing for desktop programs. But the types of programs that are out there, I mean, just about anything. There's CAD software if you wanted to draw a house. Before you build a house, you create blueprints for the house. And those blueprints are created, they used to be created by hand alone, then software came along, and now the software has gotten very, very powerful for creating your CAD drawings for your houses. Skype is an example of a program that allows you to do voice over IP, video and voice over the internet. Quicken is software that Intuit creates. It's great for doing your personal finance and your personal books, and there's 3 or 4 or 5 companies that make personal banking and small business banking software available that also helps you with your taxes and tax deductibles and printing up charts and reports and keeping up with your balance and so on. I mean, the list of software that's out there is literally all the programs available. If there's something you want a program to do, playing games, and you mentioned playing games, learning Spanish, if you go to Best Buy and just walk around their software division, they don't have that much, but they've got 4 or 5 rows just of software programs that you can get. And if you go to Amazon and just search for software, you will find there's a long, long list. Our last quick quiz here: single type of data to be included in a database, viewed as a column in a table, is called a record. So, a field within a record. Viewed as a column in a table. What I'm saying there is, if we use a spreadsheet as an analogy, I don't even want to do that because I didn't show you the graphics for that. So forget the parenthetical there. A single type of data would be a field, and then all the fields together are a record. So for a student, you have to have all the fields for that student: the name and the mailing address and the classes you're signed up for and the major of your choice and all that. Those are all fields. Together they make up a record, and all the records, you as a student, another student, another student, another student, all those students together make up a table. True or false? Question 2. Each slide in a presentation can contain only one type of element, such as text or an image or video clip. That's false. A slide can have many things on it. But good presentation styles, you don't want to be overly confusing. You want it to be visual, and you might have a little bit of text. Maybe there's a sound effect if it's really appropriate. Maybe there's a video clip instead of a still image. But slideshare.net, good place to go and look at good professional presentation skills so that you can mimic your presentations based on those. Question 3, recording content on a CD or DVD disc is referred to as burning the disc. So that's there's software programs out there, application programs out there. Kind of blurs the line between application program and utility program, but there's applications program out there that help you make sure that you have backups of all your data, and that will burn the backup content to a CD or DVD for you, and it'll help you with the recovery process if you end up having a virus or losing your hard drive and to get a new hard drive, and taking that information that you've backed up and bringing it back into your hard drive so that you can run effectively, recover from the virus. Right. So burning is the term for copying the content. Okay, I think that's it. Thank you. Have a great day.